In the previous video, we looked at characteristics of a good design. We said that a good design is modular. And by this, we saw that a good design has high cohesion and low coupling. In the upcoming videos, we will now look at how we can represent these designs or these modules using appropriate representations. So what does a module consist of and how can we capture the relationship between modules will be the focus of the upcoming videos. Now there are different ways of looking at a design. So in this course, we will be following an object-oriented design approach. So let us look at the basic concepts in an object-oriented design perspective. So as the name suggests, the key building blocks of a design in this approach are objects, right? And we imagine the working of a software in terms of interacting objects, right? And objects, they usually represent a tangible real world entity. So objects in the real world, they interact with each other to get the job done. So let's take an example of a supermarket, right? So consider you have to buy a set of things from a supermarket. So let's reflect on this for a moment. So what are the key objects you interact with to buy something from a supermarket? You can pause this video and think about the key objects you interact with before proceeding. So what are the key objects you interact with? One is you go to the market to buy something, right? So these are nothing but the products. It can be food items, clothing, etc. These are tangible objects. And after you decide what all to buy, you place them on a shopping cart or a shopping bag. So this is also an object. Then you go to the cashier and he or she creates an order, which is the list of products as well as a total bill. And then you make a payment. This payment can either be in cash or through a credit card or a debit card. So these are also tangible objects. So similarly, in software systems, we create objects which represent real world tangible entities. So now what does an object contain? Right? So an object, it contains data, right? Which is usually private or visible only to that particular object, as well as methods, which are set of functions that operate on the data, and these methods are usually visible to other objects as well. Now, a key idea in objects is that they follow encapsulation. So the data as well as the methods are bundled together or encapsulated together. And generally, data is hidden from other objects and it can only be accessed by the methods of that object, right? So no object can directly access the data of other objects. So each object can be thought of hiding its internal data from other objects, right? And this is a very important principle and it is known as data hiding or abstraction. And encapsulation ensures data hiding and data abstraction, right? And an advantage of decomposing the system into objects and doing this data abstraction is that it divides the system into parts, right, which have low coupling and high cohesion. So how does it ensure high cohesion? So data variables and related methods all are encapsulated together. So they are within a particular module, right? And hence they have high cohesion. And the interaction between different objects are minimized because of this. Because all the related methods and data variables are present in a particular object. And hence, these modules have low coupling as well. So let's take an example of a product object, right? It will have private data members like name of the product, type of a product, be the size, the color, dimensions, cost, etc. And there are various operations which we can do on the product object. For example, we can add products, we can edit particular products details, we can delete a product, and so on. So now that we have seen what objects are, another key term or concept in object-oriented designs is a class. Right? So what is a class? So class is nothing but a template by which we can create objects, right? And all objects possessing similar attributes and methods, they constitute a class. So for example, electronic items, clothes, food items, right? They are all objects of the type product, right? And all these classes can be related to other classes in several ways, right? So let's reflect on this point of how can classes be related to each other, or what are ways in which different classes can be related to each other. So you can pause this video here and write down your responses before proceeding. So one type of relationship between classes is association. And by this we mean that different classes, they take each other's help to perform some functions. So objects of one class, they invoke the methods of the corresponding object of another class. So for example, we have seen this before in if the seller wants to view his or her inventory, the seller object calls the view inventory method by passing the seller ID, right? And here we see that the seller module and the inventory module, or the seller class and the inventory class, they are related to each other. Another type of relationship is composition, right? And as the name suggests, it represents a whole part relationship, right? One class is a part of another, right? And objects which contain other objects, and these are known as composite objects. So for example, a catalog has a list of several products, right? So in the seller portal, a catalog will contain a set of products, right? And it is represented in this manner. Here you can see that products is a set of products. They constitute a single catalog. Another type of relationship is inheritance, right? So using inheritance, you can define a new class by extending the features of an existing class. So the original class is known as the base class, and the derived class or the new class is known as the derived class. So for example, instead of having a single class known as product, we can divide this into several subclasses like electronics, books, clothing, etc. Right? So electronics is a special type of product. Books is a special type of the product class. And it is represented in this manner. So for example, product is the base class. It can contain common attributes like the name, the type, the cost, etc. But books can be a subclass or a derived class which contains additional attributes or additional features like name of the author, the publisher, number of pages, etc. So it is a specialized kind of product. Another type of relationship between classes is dependency, right? So what does this mean? So if let's say we have a class B which depends on class A, and if any changes are made to class A, then changes have to be made to class B as well, right? And a common example is interfaces, right? So let's say we have an interface A and class B implements this interface. And this is a very common feature in object-oriented programming languages like Java, right? You have an interface and a class implements that interface. Now, if this interface A is changed, then appropriate changes have to be made in the class B as well, right? So this type of relationship is known as a dependency relationship. So let's say you have these different classes and you want to start identifying relationship between the different parts, right? So how do you do that? So how do you identify class relationships? So for each type of relationship, there are ways in which you can decide which type of relationship the classes have. So association kind of relationship, it means that A delegates something to B or A needs help from B. So then we know that A and B can be related to each other using an association. For composition or aggregation, if B is a part of A, or let's say if A contains B, then we know that A and B have a composition or aggregation relationship. Or even if A is a collection of B's, right? And third, for inheritance, we say that if A is a kind of B, or let's say A is a specialization of B, then A and B are related via inheritance. So to summarize, right, the past few videos, the previous videos, we looked at what do we mean by design, right? And design or software design is a way of organizing the code you will implement and providing a structure to the software system. And we also discussed what is the outcome of the design process, right? It is the different modules which are required and the relationships among these modules. So now we have a vocabulary to talk about the different modules and how these different modules can be related, or what is the relationship between these different modules. Now, an important aspect to consider is how do we communicate this design to other members of the team and sometimes even to the clients, right? And this is important, right? And this can be done by creating a model of the system to be built, right? And in the next video, we will look at how we can effectively represent these kind of designs so that it can be communicated easily to other members in the team and even to the clients. We will be using a popular modeling language known as UML or Unified Modeling Languages to represent the given design.